Hello everyone and welcome to David's math class. In this video I will show you another geometry problem which I found interesting. It has little details but asks us to find the measure of an angle. So in this diagram we have an isosceles triangle ABC where AB is equal to AC and ABC is equal to ACB, measure of 40 degrees, and we have a point D on this ray AC so that AD is equal to BC, and we have to find the measure of angle ADB, which we have assigned alpha. So how can we go about this problem? Well, for starters, we have to construct a few lines, and I will just clear this up for you. Alright, so first things first, because we know that BC is equal to AD, which is equal to AC plus CD, I would like to subtract CD so that we have two equal sides here. So we know that BC is equal to AD. Then that means BC is equal to AC plus CD. Then that means BC is equal to AD plus CD, since this triangle is isosceles. Now we construct point E right here such that this triangle ABE is isosceles. So let E on segment BC so that BA is equal to BE. We have that these two are equal, and also notice that here we have BC is equal to BE plus CD. But notice that BC is also equal to BE plus EC. So if we subtract BE, so we subtract BE, we have that CD is equal to CE, which means that this triangle is isosceles. Good. Now I just clear this up. Alright. And now, because this triangle is isosceles, then those two angles are equal. And not only that, but their sum must be 180 minus 40 degrees. So, really, we will calculate the measure of those. So we have that BAE is equal to BEA, which is equal to 180 minus ABE over 2, which is 180 minus 14 over 2, which is 140 over 2, which is 70 degrees. Alright, then we clean this up. So instead of these little marks, we're going to put 70 degrees. 70 degrees. Perfect. Right here. Now, since BAC is isosceles, then we have, knowing that AB is equal to AC, that BAC is equal to 180 minus twice ABC. That would be 180 minus 2 times 40 degrees, which is 100 degrees. Alright, and since this plus this is BAC, that means that here we have a 30-degree angle. Now, we notice that this is also an isosceles triangle. So we have that CE is equal to CD, which means CED is isosceles. And that means that CED is equal to CDE is equal to 180 minus ECD over 2. ECD is 180 minus ACE, and that would be 180 minus 40 degrees, and this will be 140 degrees, which means that CED is equal to CDE, which is equal to 180 minus 140 degrees over 2, and this is 40 degrees over 2, and this is 20 degrees. Alright, so here we have 140 degrees, 20 degrees, 20 degrees. Now here's the crazy part. We let F be the symmetrical projection of E on this line. So it will have the symmetrical projection of E to this line, AD. So we'll have something like this. All right. And here's the cool part, because this is the symmetrical, it means that FAD is equal to EAD, which is equal to 30 degrees. Nice. It also means that here FDA is equal to EDA, which is also equal to 20 degrees. 20 degrees. All right. And now here's another cool part. AE is equal to AF, true symmetry, and also DE is equal to DF. All right. So these two are equal, and then this is equal to this. Good. Let's observe something. So FAE is twice EAD, and that's twice 30 degrees, and that would be 60 degrees. But we also have that AE is equal to AF. This means this is an isosceles triangle with a 60-degree angle. So this AEF will be equilateral. All right? And now that means that AE is equal to EF. Great. So we draw this, and we notice that these two are equal. And now I will clear up the figure for you a bit. But before that, let's notice another thing. FD, this is twice 20 degrees, and that is going to be 40 degrees. All right? Now I'll clear up the figure for you. Then let's notice the following. AB is equal to FD, which is equal to 40 degrees. And now AB is equal to BE, and DF is equal to DE. And if we divide these together, we end up with BA over DF is equal to BE over DE. And since ABE is equal to FDE, notice these two sides are opposite to these angles, and then opposite to the 40-degree angle is this last side. So from this we can get the fact that ABE is similar to FDE. So this is the side angle side case, and from this we get that BE over DE is equal to AE over EF. But recall that AE is equal to EF, which means that AE over EF is 1. And then that means that BE over DE is 1. And that means that BE is equal to DE. Okay, so we have this amazing construction, and now let me show you what we're left off with. Alright, so recall this diagram. Recall that these two are equal to each other, and also recall that this is a 20-degree angle. So from this we can derive the fact that BD is isosceles with EB equal to ED, which means that EDB, so this angle EDB, is actually equal to 180 minus BED over 2. But 180 minus BED is equal to CD. So this will be CD over 2, which is equal to 20 degrees over 2, which is equal to 10 degrees. So this angle is 10 degrees. And now, finally, because in the original diagram we had to find alpha, and alpha is the following. Let me make it in blue so that we can differentiate it. Alpha will be equal to 20 degrees plus 10 degrees, and finally we get that alpha is equal to 30 degrees. And that's our answer. Thank you so much for watching. Make sure to like the video and subscribe, and see you in the next math class. Goodbye.